The internal combustion engine functions like an air pump. It draws in air, mixes it with fuel, compresses it, and produces power through combustion. The more efficiently an engine can move air, the more power it can generate. Two important concepts that help us measure engine performance are horsepower and volumetric efficiency. Horsepower tells us how much work the engine can produce over time. It depends on the torque the engine generates and how fast it is spinning, measured in revolutions per minute, or RPM. The relationship is given in the formula shown on your screen. We take RPM, multiply it to torque, whose units are pound-foot, and divide that by 5,252. The number 5,252 is a constant that comes from converting units so that torque and RPM can be used to calculate horsepower. Volumetric efficiency, denoted VE, measures how effectively the engine fills its cylinders with air. A high VE means the engine is breathing well, which often translates to better power output. It's calculated using the following formula. We take the actual airflow volume, which is something that a technician can measure, divided by the theoretical or possible airflow volume, multiplied by 100%. You'll see both horsepower and volumetric efficiency calculations in the upcoming examples. Understanding how they are related helps explain why performance upgrades like turbochargers, high flow intakes, and performance cams often lead to noticeable increases in engine output. Let's begin with question number 1. A 4.6-liter engine is being measured for power output. At 4,000 RPM, the torque value of the engine is 235 foot-pounds. Calculate the horsepower produced at this engine's speed. What we do to calculate horsepower is we take the RPM of 4,000, multiply it to the torque of 235, and divide that by 5,252. Let's use our calculator. 4,000 multiplied to 235 divided by 5,252. 178.98 rounded to 2 decimal places. 178.98 horsepower. In question B, at what RPM will the engine produce 200 horsepower? So this time we're looking for the RPM and we've been given the horsepower. We do have to work backwards. I'll substitute in for HP 200. RPM is unknown, so I'll just denote that as X. Now, the torque hasn't changed. It's still 235. So we will multiply this by 235 over 5,252. And to solve for X, all we have to do is rearrange using some algebraic techniques. We multiply both sides of the equation by 5,252. That cancels out the denominator, which leads us to the following equation. Then we evaluate the left side and divide both sides of the equation by 235. Let me show you what I mean. We'll evaluate the left side, 5,252 times 200. We get that output, and the right side still X, 235. And then we divide both sides by 235. Notice how this cancels out the 235 on the right side. So on our calculator, we take the value on our screen, divide by 235, and we end up getting the engine speed required to produce 200 horsepower. And that's 4,469.7. And we will round this to the nearest whole value just for simplicity's sake. And if we do, we end up getting 4,470 RPM. That's the answer for question B. For question 2, we're asked, a 4.6-liter engine is being measured for volumetric efficiency. An upgraded intake design promises the engine to flow 600 cubic centimeters of air, while the current actual airflow is 35 cubic inches. Calculate the volumetric efficiency. Note that the units are off. This one is in cubic centimeters, and the units of the actual airflow is in cubic inches. So if we were to substitute these values as they are into this formula, we would end up getting something like 35 cubic inches divided by 600 cubic centimeters, which I'll call cc for short. Or you can call it cm to the power of 3. Now, in order for us to calculate the volumetric efficiency, these two units need to be the same. So you need to convert either one to the other. And don't forget to multiply by 100% afterwards, or a factor of 100. Let's change 35 cubic inches into cubic centimeters. And we'll use this conversion factor chart here. So we have 35 cubic inches, and we'll multiply this by, we have cubic inches to cubic centimeters right there. So I'll put 1 cubic inch at the bottom, and at the top I'll write in 16.3 cubic centimeters. And what this will do is cancel out the cubic inches, leaving us with an answer in cubic centimeters once we multiply those two numbers. And when we do, we end up getting 570.5. So I'm going to go ahead and replace 35 with 570.5. So I'll erase this part and write in 570.5. Again, this is the measured airflow volume. So this was something that a technician actually found. We take this value now and divide it by 600, then multiply by 100% or a factor of 100, and this gives us a volumetric efficiency of 95%, roughly that, 95% efficiency. If you have any further questions about the topic you just learned, please leave it in the comment section below. Thank you for watching.